So analysis of cost behavior, second part is describing the learning objectives of those. This part is describe the impact of a time as a cost driver. So time, as we know in the beginning, we discussed that there is some variable cost, there is a fixed cost. This variable and fixed cost is based on a time. In a certain time frame, in a certain period of time, some costs are variable, some costs are fixed, but over a long period of time, when there is a no restriction over time, then every cost is a variable cost. Describe quality controls and its implication as a cost driver, and understand the issues of data collection and quality. So these are the three things what are the learning objectives of our second part. Time as a cost driver and as a competitive tool. So companies view time as a driver of a strategy, because the companies have to change their strategies, change their capacities, change their over a longer period of time. So that's a time is so operational measure of time, how quickly firms respond to customers' demand for their products and services, and their ability in meeting scheduled delivery dates. Now, how we measure these times for our customer's response time, how long it takes from a from the time a customer places an order for a product or a service is delivered to the customer. So that's a time, overall time, that when the customer requested and when the product is delivered or a service is delivered. Like someone is asking for a doctor's appointment, so we see from the appointment, taking an appointment, from that time till the customer is visited the doctors, or so that's a one measure of time. The other measure of time is a manufacturing cycle or a lead time. We call them as a lead time as well. How long it takes from the time an order is received by a manufacturing to the time a finished goods is produced. That's what we call it as a lead time. The main the you receive an order, like in some industries, we are not producing before the order. If you book a car from any company, Honda, Toyota, wherever, whoever. So what is going to happen is that you place an order, and normally nowadays the delivery times are very long, like more than an hour, year. So in this time, this is what we call it as a lead time. That when you place an order and when you get your product, manufactured product, that's what we call it as a lead time. So on time performance, delivering a product or a service by the time it was scheduled to be delivered. This is a way to measure the performance of an organization, that they promise, okay, we will deliver your car within the 3 months, and you get it within the 3 months. That is a on-time performance. Now, this uh, uh, graph is representing these all time frames that what we are discussing. So here we are saying that customers place order for product. That's a time starting. That's starting time, and order delivered to customers. So this whole time, what we call it as a customer response time, right? That's what I mentioned in the beginning. But this production customer's response time is further, we break down into three components. Then one, what we call it as a receipt time, that we receive an order, customers place an order for the product, and order received by the manufacturing. That's what we call it as a receipt time, because there's a different departments, and you place an order with the sales department, and then sales department reported to the manufacturing unit. That's called as a receipt time. Then from a order received by the manufacturing unit till the product is finished and ready to delivery, that is called as a manufacturing cycle time. They produce the product and deliver to the warehouse that this is ready to deliver. Now, the other part is again the sales department work, that they inform the customer, and this customer will come and pick up, or you have to deliver the product to the customer. So that's again the selling department or the other department job. So the manufacturing department job is finished at that point, and that's what we call it as a manufacturing cycle time. And then there's a delivery time. It can be through courier, or to call customers, and all these process. So we see here that the customer response time is broken down into three time frames. And then this manufacturing cycle time is also divided into two. The waiting time, that you place an order for a car and that car is not under manufacturing process right now, because they process in a way that certain models are manufactured and then change the plant system, and then they produce the other models. So that's what we call it as a wait time, that how much they have to wait till the start of that. The machine setup begins for order, and then we have to produce. Orders manufactured, produce becomes finished goods. So we this customer response time illustrated in a way that we can, when we are talking about customer response time, this is the time from ordering to the delivery. When we are talking about the receipt time or a manufacturing cycle time, delivery time, these are different time periods. And wait time and manufacturing time. So time drivers is any factor in which a change in the factor cause a change in the speed of an activity. So we can improve these time, how we can improve these times to reduce the customer response time. We can reduce the receipt time. We can improve the delivery time through changing our couriers or all these things. We can improve the manufacturing time by reducing the waiting time and also manufacturing time. So two time drivers: uncertainty about when customers will order product and services. We don't know exactly when the customer will call and place an order, or the customers place an order. Bottlenecks due to limited capacity. A bottleneck occurs in an operation when the work to be performed approaches or exceeds the capacity available to do it. Uh, Definitely, every industry has its own limitations for your capacity. So that these are the two time and drivers we have to consider. Simple time presumptions. When demand uncertain is high, some unused capacity is desirable. Like, we don't know exactly when the customer is going to ask for the product. So in that case, we have to keep certain capacity as an idle or unused capacity, as compared to we are not able to reduce the capacity. Because if there's no demand, okay, we reduce the capacity. No, we have to keep certain capacity as an idle if the demand is uncertain. Increasing the capacity of a bottleneck resource reduce the manufacturing lead time and delays. So reduce setup times, invest in a new equipment to increase capacity, and careful scheduling of production. So by these are the ways that through which we can improve or we can reduce these times. Quality. That's a quality as a competitive tool, because in a competitive market, in a monopolistically competitive market, we are selling the product on the basis that our product is better or best as compared to others' products. So quality is an important way that we can compete with the others. So the total feature and the characteristics of a product or a service made on perform according to specification to satisfy customer at the time of purchase and during use. So the quality focus reduce cost and increase customer satisfaction. So increased customer satisfaction is also beneficial for the business in a way that increase in the sales, or that increase the reputation or a brand name of the company, and by this way they are able to sell more. Focusing on the quality of a product will generally build up expertise in producing it, lower the cost of making it, create and customer satisfaction for customer using it, and generate higher future revenues for the company selling it. Just as I mentioned, that build up the reputation of the company. Two basic aspects of a quality. One is a design quality, that the product should be designed in such a way that that is going to help them in the best performance. So refer to how closely the characteristics of a product or service meet the needs and the wants of the customer. And conformance quality refers to the performance of a product or service relative to its design and product specification. How we can improve the quality or cost of quality. Four categories of a quality cost. First of all, we try to preventive cost, incur to preclude the production of a product that do not conform to specification, so that there is a check and balances when an order is received. So we try to make sure that the product is according to, or the order is according to the customer's demand. If that's a prevention, that we stop it to produce a product which is not according to specification, or we can create a system that the product is not deviated from the customer's demand. Appraisal cost incurred to detect which of the then after production there is another inspection, or we can say appraisal, that incurred to detect which of the individual unit of product do not conform to the specification. Internal failure cost incurred on defective products before they are shipped to customer. So we have to do a rework on it, or reproduce the product if it is not according to the customer's specification or requirement. So prevent it if it is, we call it as a preventive before the production, what we spend cost to make sure that the product is according to the requirement. If And then after production we have to do a quality control check, or a check that has a cost, because you have appoint someone from an expert to audit or to appraise that cost. That's appraisal cost, and audit cost, or an appraisal cost. And then if it is a internal failure, then we have to do a rework on it. That's a cost again. And if it is shipped, and then there's a cost that the customer is going to return it, and then you have to deliver a new product, as well as that creates a bad impact on the customer about the firm. So that's incurred on defective products after they are shipped to the customer. So these are the cost attached with the quality. If the quality is not one is before the start of the process of a production, and one is after the start finish the production. But if at these points it is not identified, then there is a possibility of an internal failure. Like if it is identified at the time of appraisal, then we have to rework on it. And if it is not identified there and the customer is not satisfied, then there's an external failure cost for that. So prevention of design engineering, process engineering, supplier evaluation, preventive equipment maintenance, quality training, test of new materials. So these are the preventive costs. What are the appraisal costs? Inspection, online product manufacturing and process inspection, product testing. And then internal failure cost, spoilage, rework, scrap, machine repair, manufacturing process engineering on internal failure. And external customer support, manufacturing, process engineering for external failures, warranty repairs, cost, and liability claims. So these are the cost attached with the uh, quality. So control charts, how we can control this whole process of quality control. Statistical quality control is a formal means of distinguishing between random and non-random variation in the operation process. Control charts are a part of a SQC, statistical quality control. Control charts are a graph of a series of successive observations of a particular step, procedure, or operations taken at a regular intervals of time. Each observation is plotted relative to specific range that represents the limits within which observations are expected to fall. Only those observations outside the control limits are ordinarily regarded as a non-random and worth investigating. So here is an example, like we are finding out the defect rates. So this mean line is our average line. And we see that there are certain observations which are one standard deviation within one standard deviation, and there are certain observations out of one standard deviation. Uh, so this is a production line A, and this is a daily observation. This is a production line B. This is a observation, and this is a production line C observation. So we see here in this case there is a particular phenomena that the defect rates are increasing. So we have to go over this, why they are happening. Pareto diagram is also used statistically to observe that how much deviations or defects we can observe. So observation outside control limits serve as an input for Pareto diagram. So Pareto diagram, a chart that indicates how frequently each type of defect occurs, ordered from the most frequent to the least frequent. So we see here the type of defects. It's a bulb manufacturing company. So copies and it's a photocopier machine company, Xerox. Copies are fuzzy and unclear. Copies are too light or too dark. Paper gets jammed. Copies are not square or on page. Toner is smudged on page and paper is not feeding properly. So these are the and that's going to help the department for that which problem is existing more frequently. So this data and the Pareto diagram helps them to figure it out that which. Now, this is a cause and effect relationship or a diagram. Identify potential cause of defects. Problem identify. Pareto diagrams are analyzed using cause and effect relationship, also called as fishbone. You see that this diagram is like a fish bones diagram because they are resemble the bone structure of a fish. So we see here that how many human factors are possible for these defects. Poor training, new operator, inadequate supervision. Uh, Machine related factors can be poor maintenance, poor machine parts, incorrect speed, and inadequate measurement tools. Methods and design factors like flawed part design, incorrect manufacturing sequence, and material and component factor can be also possible. Multiple suppliers, a variation in purchased components, merchandising of a purchased mishandling of a purchased parts or incorrect component specification. So these are their different way that we can identify that where there is a problem exist for our quality. The ideal debate for estimating cost function has two characteristics. The debate should contain numerous reliable measured observations of the cost driver, the resource consumed, predictor variable, independent variable, and the related cost. So the database should contain numerous reliable measured observations of the cost driver. The resource is consumed, that can be a driver, a predictor variable, that can be a driver, independent variable, and the related cost. So these are the all the data base should be built on these variables. In relation to the cost driver, that the database should consider many values spanning in a wide range. So we can also collect the data regarding other things as well, not only dependent and independent variable. The time period for measuring dependent variable does not properly match the period of measuring. Now, what problems can arise in our data? Uh, the time period for measuring the dependent variable does not properly match the period of measuring the cost drivers that are independent variable. So encourage use of an accrual accounting to mitigate that problem. Fixed costs are allocated as if they are variable. So distinguish carefully between fixed and variable costs so that data are either not available for all observations or are not uniformly reliable. So minimize manual gathering of data and follow up on all discrepancies. Extreme values of observation occurs from errors in recording cost. Adjust for or eliminate all unusual observations. Means outliers. We have to exclude the outliers. Data are either not available for all observations or are not uniformly reliable. So we minimize manual gathering of data and follow up all discrepancies. Number 6, there is no homogeneous relationship between the cost driver and the individual cost items in the dependent variable cost pool. So homogeneous relationship exists when each activity whose costs are included in the dependent variable has the same cost driver. Should estimate separate cost functions for each activity, and the relationship between the cost driver and the cost is not stationary. So pool data to ensure a larger data for the estimation, and inflation has an effect cost the drivers or both the specific inflation as a second predictor variable. Now the last point is more related to economics. Now, when we are calculating the cost drivers and we are comparing with the data over a long period of time. So the data can face a problem of this, that because of inflation, if the input prices change or increase from the previous period from which we are comparing, so that can create a problem in our developing a relationship between output and input. So we have to be careful about the inflation, or we have to, when we are taking a data for a period in which there is a lot of inflation, so we have to adjust those, or we have to adjust the data according to the inflation effects on there. So this is all about the cost behavior, analysis of cost behavior. The main objective of this is to develop a model, is to develop an equation, or in which we can, based on our previous historical data, that we can predict for the future that, okay, if we produce or estimate for the future, if we produce this much output, how much cost is going to be is going to be happen, because the fixed cost is there and the variable cost is there. So we just have to figure it out, that with the level of this level of our activity or this level of output, how much is the cost is going to increase, and how the cost is going to behave when we want to produce this much of quantity. So this is a very, it's not cost accounting type of chapter. It's a chapter in which we more talking about the statistics, regression analysis, high and low income method for calculating those coefficients for our equation of cost. So this is a just focus on some statistical tools, and also theoretically explaining that how we can use to reduce the cost. And there are many ways they explain that, for the from the defect point of view, or from the time consumption point of view, and from the experience point of view. So these are all the things that that affect the time, that affect the cost, the customer response time, and also uh, uh, the quality of the product. Like if there is no defects, then definitely the cost will reduce. And the thirdly, which we discuss not so much, but the importance is that with the passage of time, when our labor is going to be more experienced, so the learning effect is going to reduce our cost. So this is all what I want to discuss from this chapter, analysis of cost behavior, part one and part two. So if you guys have any question, you can email me, or you can write below the comments of my videos on YouTube.